Hello, everyone, and welcome to the Apalachicola Chattahoochee Flint River Basin Drought and Water webinar for the month of June. My name is Rachel McGuire, and I'm with the Auburn University Water Resources Center located in Auburn, Alabama. If you are new to the webinar, we'll have time for comments, questions, and discussion at the end following our last speaker. Feel free to use the question box on the GoToWebinar tool panel to type in your questions, or you can raise your hand by pushing the hand icon on that same tool panel. Our speakers today will be David Zierden, the Florida State climatologist at the Florida Climate Center at Florida State University. He'll speak with us about our current drought status, seasonal forecasts, and outlooks. We have Tom Littlepage, branch chief of the Alabama Office of Water Resources with State of Alabama input. We have Paul Anghorn of the USGS South Atlantic Water Science Center sharing stream flows and groundwater conditions for the ACF. We have Jody Wan of U.S. Army Corps of Engineers Mobile District with our ACF reservoir conditions. We also have Samantha Lucas of the Apalachicola Bay National Estuarine Research Reserve with Salinity Index information. And we have Todd Hamill of the National Weather Service Southeast River Forecast Center with our outlooks for the ACF. And lastly, we have a special guest today, Mike Hobbins of the Cooperative Institute for Research in Environmental Sciences, which is a partnership of NOAA and the University of Colorado at Boulder. He'll be talking with us about EDDI, the Evaporative Demand Drought Index. And without further ado, I'll get things started with our first speaker, David Zierden, when you're ready.
Okay, yeah, thank you very much, Rachel. Can you hear me?
Yes, I can.
Okay, we say that every week, but I think we got all the bugs ironed out. So we'll go ahead and begin with what's in the news this week or these past few weeks, and hopefully it's not going to be a recurring theme all the season long, but it's the tropical season is certainly in the news with the landfall of Tropical Storm Claudette. Pretty early for a storm to be hitting the northern Gulf Coast, and it certainly impacted just about every piece of the ACF basin. Over on the left, you see the visible satellite loop of the center of circulation making its way across Alabama, Georgia, and South Carolina. And you also see an older forecast of the track, which is kept pretty true to as it traversed the southeast United States and back out into the Atlantic Ocean. So we'll take a closer look at some of the impacts from this first tropical storm of the season on the next slide. And certainly severe weather came along with Tropical Storm Claudette. Over on the left are the storm reports from June 19th, and we see many reports of wind damage across the western Florida Panhandle and southern Alabama, but also even more critical, a couple tornado reports from South Alabama and near Blakely, Georgia on the Alabama-Georgia line. Did significant damage. Thankfully, there were no direct deaths from the tornadoes, but there were 14 deaths related to Tropical Storm Claudette. The most tragic is 9 children and 1 adult were killed in a weather-related vehicle crash with a passenger van due to flooding and water on the road. So certainly a tragedy there, and just a good reminder that these tropical systems bring all variety of threats, from inland flooding to severe weather to wind damage. You can't concentrate on just one threat. So on the next slide, we'll take a little more related look on how it affected the drought, and it certainly brought plentiful rainfall across the southeast and to all portions of the ACF basin. But also there's been a kind of a 1-2 punch that now we're looking at a sagging and and slow-moving cold front across the southeast. That's focusing a lot of rainfall across the Florida Panhandle and South Georgia today. Over on the left is the surface analysis from this morning, and on the right is a radar loop that's a few hours old, but it just does show the continued heavy rainfall across the Florida Panhandle and Big Bend area and extending up into South Georgia. So this was on top of the rainfall that already occurred the previous few days from Tropical Storm Claudette. So on the next slide, we'll kind of put this all together, and this shows the 7-day precipitation totals as of this morning from the tropical storm and also this stalled frontal system. We see very heavy amounts across southern Mississippi, southern Alabama, everywhere, the Florida Big Bend, the Florida Panhandle and Gulf County. Everywhere we see these pink colors, that's 7-day totals of 10 inches or more. But also we see widespread coverage of anywhere from 2 to 5 inches or more across nearly all of Alabama and the western half of Georgia, including all of the ACF Basin for the most part. So very heavy rainfall over the past week due to the Tropical Storm Claudette and now this slow-moving frontal system. We also see good amounts across the Big Bend of Florida and Northeast Florida, which will be important on the next slide or two. And speaking of that, this is the current U.S. drought monitor as of last Thursday, and a fairly broad area of abnormally dry was introduced to North Florida and South Georgia due to basically 30-day rainfall totals being well below average, especially at a time when temperature and evapotranspiration is really high. But again, due to this recent rainfall, we anticipate all of that abnormally dry being removed this Thursday when the next iteration of the drought monitor comes out. Not as much relief for South and North Carolina and Virginia, nor for South Florida, where the rainy season has commenced, but it still hasn't been robust enough to eliminate all the abnormally dry or even moderate drought that exists down in South Florida. So on the next slide, we'll take a look at recent rainfall, or first we'll look at the Lawn and Garden Moisture Index from University of Alabama, Huntsville. Here we see very moist conditions across all of Alabama, most of Georgia, most of the Florida Peninsula, and keep in mind this was a little older image for the morning of June 21, so it doesn't account for all the rainfall that occurred across that North Florida, South Georgia region in the past 24 hours. So we expect this product to look even better when it comes out tomorrow morning. So on the next slide, we'll start taking a look at actual precipitation accumulations over the last 30 days. And this really tells the story. We see all these areas that are shaded in pinks and purples of 30-day rainfall totals of 10 to 15 inches or more in even some locations. South Alabama, the Florida Panhandle, certainly southern Mississippi, and then again across the northern portions of those two states, broad area of 10 to 15 inches over just the last 30 days. A little further east, where we actually look at the ACF Basin, not as heavy amounts, but still a good coverage of 6 to 8 inches or more in most locations. So a very good month for rainfall across the ACF Basin, and catching up some of the accumulating deficits that we had been seeing as of just last week. On the next slide, we'll take a look a little further back, and now this is 90-day departures from normal, and this tells much the same story. Nearly all of Alabama well above normal for precipitation over the last 90 days or 3 months. Again, looking closer at the state line between Alabama and Georgia, the ACF Basin is mostly above normal, some spots closer to normal, but mostly above normal over the last 90 days. We still see a little bit of remaining dryness in North Florida and South Georgia, but I think that'll be wiped clean with the rainfall we're getting today. So on the next slide, we'll start taking a look ahead, and it looks like this troughing over the eastern United States and this kind of stubborn frontal boundary will remain a player for the next few days. Heavy rainfall amounts are forecast for the Florida Panhandle and South Georgia. Amounts of 3 to 4 inches are possible over the next 7 days. A little less in the middle and upper ACF basin. So on the next slide, we'll take a look a little further out, and I like at this time of year to look at the week 2 forecast from NOAA's Climate Prediction Center. And looking over at the left at the increased chances of below normal temperatures over the southeast United States, and also increased chances of enhanced rainfall over that same region, says that the models are advertising that this kind of persistent troughing and frontal boundaries will remain kind of in place for the week 2 time period. So it looks like a pattern we're going to be kind of stuck in for the foreseeable future. On the next slide, we'll look a little further out, and again, we always like to take a look at the state of the Pacific Ocean and any vestiges of the cold water along the equator or the La Nina conditions that existed all throughout the fall and winter have now disappeared. We now see that equatorial Pacific is near normal or even edging towards above normal if we look at this classic El Nino region. And the classic Nino 3.4 index at the bottom doesn't really show that. But it does show that we've been well within that half-degree threshold of neutral conditions since about mid-April. So with the Pacific and neutral conditions, we'll look at the forecast going forward, and very high probability that neutral conditions remain through the summer season, June, July, August, and even July, August, September, with probabilities of nearly 80% of remaining in the neutral conditions. Something we will have to watch is as we get into the fall, especially that November, December, January timeframe, they're now showing that a return to La Nina conditions is as likely as any other phase, or over 50% likelihood that we might return to La Nina conditions. Again, this is a hard time of the year to forecast that, and it's a wait and see type thing, but it certainly either neutral or La Nina is what we're going to be looking for as we go into next fall and winter. And over on the right is just the forecast plume from the different forecast models for the sea surface temperatures in this region. And there's a pretty good spread, but the ensemble average is around 0, which kind of reinforces that thought that we'll remain in this neutral phase. So bearing in mind that we're looking at neutral conditions, we'll look at the 3-month seasonal outlook from NOAA's Climate Prediction Center. And over on the left, we do see for the deep south, equal chances for above and below normal temperature, where the rest of the country is heavily weighted towards above normal temperatures. And if we put that together with the precipitation forecast on the right that continues to favor above normal rainfall, it seems like the models are favoring kind of a persistence of this troughing over the eastern United States, cooler temperatures, enhanced rainfall. So that's what our seasonal outlook is looking for this summer, and it looks like better than average chances of above normal rainfall. So on the next slide, we'll just take a quick look at the seasonal drought outlook. And this was released before that area of abnormally dry was introduced and then quickly going to be taken away from North Florida and South Georgia. But since most of the Southeast is relatively drought free, this product reflects that, and especially with the favorable forecast for rainfall, really no issues with drought development over the next three months, according to this product. So with that, I'll go ahead. Let me just mention the seasonal hurricane forecast. Again, in last month's Greater Southeast NIDIS webinar, Matthew Rosenkrantz did a great job of explaining NOAA's seasonal hurricane forecast. And it's actually very similar numbers to the forecast that was released at this time last year, when we ended up having a record-breaking Atlantic hurricane season. So it's still a fairly strong forecast for above normal activity, 60% chance of above normal, only a 10% chance of below normal hurricane activity. And very interesting, on the bottom is just the climatology of where these tropical storms and hurricanes form during the last third of June and the first third of July. And looking at the last of June, we still see a lot of development activity in the Northwest Caribbean and the Western Gulf of Mexico, which is coincidentally where Claudette formed. But as we get into July, activity in the Gulf of Mexico and Caribbean seems to die down a bit, while development is more favorable in the main development region in the Atlantic Ocean off the coast of Africa. So whether that's just a real part of our climate or just small sample size, we'll keep an eye on it, but it's certainly good news if there's less development in the Gulf. So with that, we'll go ahead and summarize. Tropical Storm Claudette impacted all areas of the ACF Basin, from heavy rainfall to severe weather. Normally dry conditions are rapidly improving across North Florida and South Georgia, and the rest of the ACF Basin remains drought-free. And we're looking at above normal rainfall over the entire ACF Basin the last 30, 60, even 90 days out. It does look like troughing and sagging frontal boundaries will continue to bring rainfall and unsettled weather to the northern Gulf Coast, certainly for the next week or two. In the Pacific Ocean, neutral conditions will prevail. However, we'll keep an eye on this fall when there is up to a 50% chance of La Nina returning. The CPC's seasonal forecasts favor above normal temperatures, but also lean even more heavily towards above normal rainfall for the next 3 months. And the NOAA hurricane forecast, seasonal forecast, again, calls for active seasons, 60% chance of an above normal year. Down here in Florida and even South Florida, the rainy season has begun for the whole state. And the hydrology of the ACF is in very good shape going into the summer season, when we usually start to dry out.
Thank you, David. And now I'll turn it over to our next speaker, Tom Littlepage, who it looks like he actually could not join us today, so I'll present on his behalf with the state of Alabama input. So David's already covered a lot of this. Right now, the current U.S. Drought Monitor has Alabama completely drought-free. The current Alabama drought declaration was released on May 11th, and there was no drought declaration for any of the 9 regions of the state. We'd like to let everyone know that there is an Office of Water Resources website where you can report drought impacts. And there's a link to that here. I'll also include that on our follow-up email if that's of interest. Rainfall and improved stream flows have eliminated all of the USDM drought designations in Alabama. I already mentioned the drought declaration from May 11th has no drought designations. There's also no reported water availability issues, and the next Monitoring and Impact Group, or MIG, meeting is scheduled for Tuesday, July 13th, 2021 as a virtual WebEx meeting. If you'd like more information about that, you can contact me after this meeting. And now I'll turn it over to Paul Ancorn with our stream flows and groundwater conditions when you're ready, Paul.
Hey, Rachel. Good afternoon, everybody. So we'll begin on to the next slide here with real-time conditions across the Southeast. The map on the left is from the previous webinar, and map on the right is current as of this morning. And obviously from Claudette's impact, you see elevated flows in Alabama. indicated by black and blue dots. That's moving across the state of Georgia there. So northwest Georgia is seeing high flows. And then as we transition eastward, a little less flow at the moment. However, we do anticipate these to increase in flow as flow moves down through the basins, through the Okmulgee into the Altamaha Basin and so forth. So ACF Basin is right now just ranking at above, much below, and actually some stations are ranking as high. And so, yeah, a lot of water showing up in the last few days here. So we'll move to the next slide, and we will look at the below normal 7-day average stream flow. So you can see not a lot of change from the last webinar. So this graphic shows an average of the below normal 7-day. So it's an indication of hydrologic drought. So the image on the bottom does show Basin or 2 in the Florida Panhandle there ranking as extreme hydrologic drought. However, this is a lagging indicator, so it hasn't really taken into account the recent rain from Claudette and of course the low pressure that's moving through, as David pointed out. So I would imagine that to actually be gone in the next day or so. So looking good across the ACF. Now we'll move down into the 28-day average. So that's indicated by the black line, and then historic values for the period of record for each gauge are ranked accordingly. And again, that 28-day average is a daily mean average for the previous 28 days. So it's indicating the basic trend that we're seeing in the watershed. So these two gauges are Lake Lanier inflows, and as you can see, right now we're pretty much spot on the middle of normal inflows for Lanier. It's worth pointing out the slope of the 28-day average is roughly following the kind of the decline in flow that we see, moving from May into the summer months. So inflows looking pretty good. Well, next slide we'll look at flows out of Lanier. So Chattahoochee River at Atlanta is currently ranking in above normal, and then Chattahoochee River at Whitesburg is right at the 75th percentile, just crossing back into above normal from the normal range. All right, well, next slide, move further downstream to Chattahoochee at West Point. Again, we're seeing just a reduction in flow since our last webinar, and just crossed now into normal flow for West Point. And then Columbus also showing the same downward trend, but well into the normal expected range. All right, Rachel, next slide. We'll hop over to the Flint River. A bit of a different story here from the last webinar. You can see that 28-day average slope really dropped off, and, showing a decrease in 28-day average flow over the past 4 weeks or so. So they were heading towards below normal, but I believe once we start seeing the increased flows moving down from Claudette, we would expect these to both uptick and remain in normal conditions for the next 4 weeks or so. Next slide. Again, the same picture at Albany and Bainbridge, both hovering right around the 25th, 26th percentile. But again, I would imagine these flows to increase over the next week or so. And the next slide will be our most downstream station that we report. That's Apalachicola River. And again, that has decreased since our last webinar. With the 28-day average flow there is right around the 25th, 26th percentile. Still within normal range. And again, we anticipate it will increase as a result of Claudette. Okay, now we'll switch gears to groundwater. So last image or previous brief is on the left, current brief on the right. So basin-wide, not a whole lot of change. Well elevations are ranking anywhere from above normal to much below normal. But as a whole, majority of the stations are showing normal conditions with regard to groundwater in the basin. So we have two wells that we look at. They're both circled there to the southwest of Albany. Our first being Miller County. The image on the left, the graph on the left is the past 4 weeks. So we're just seeing daily fluctuations with well elevation there. And then compared to historical observations, daily observations, it's showing that Miller County is well above the median and that we are currently ranked in normal conditions for Miller County well. And next slide is Doherty County. So we see a little bit more fluctuation here. And again, the image on the left shows the previous 4 weeks. And then that data plotted with historical means. And although we see the fluctuation there, well conditions are currently ranking above normal. We're about 4 feet above the median observation for the period of record. Okay, so last slide here will be our summary. So real-time stream flow in the ACF basin currently ranked from much above normal to much below normal, which was really just one station that was ranking there. The below normal 7-day average stream flow indicates the ACF basin to be hydrologically drought-free. 28-day average stream flow for the Chattahoochee is currently ranking normal to above normal. And pardon me, 28-day average stream flow for the Flint River currently ranks into the normal range. And then, as I just pointed out, are currently ranked normal and above normal. Sorry, I'm taking a call from the field here. So that wraps it up, Rachel. Thanks very much.
Thank you, Paul. And now I will turn it over to Jody Juan with our reservoir conditions when you're ready, Jody.
Thank you, Rachel. If you could go to the next slide. Hi, everyone. So first off, Lake Lanier or Beaufort Dam. So with this particular reservoir / basin, we're looking pretty good with the rain that we got from Tropical Storm Claudette. It looks like we're just about to hit top of conservation, so the storm definitely helped us. And so in our next 5 weeks, we're looking to at least hit a little bit. Even with the storm that's coming in, we should hit top of conservation. You could go to the next slide, please. West Point. So we're currently above top of conservation with Tropical Storm Claudette. We are looking to at least bring that pool elevation back down to top of conservation before this next storm hits, and that'll entail much more generation than what we've been seeing in the past 2 to 3 weeks, given that we did get around a couple inches of rain at this particular project. If you could go to that next slide. Thank you, Rachel. For Walter F. George, we're looking to be almost at top of conservation currently, and we will be slightly above. I do want to let everyone know that most of these graphs have been updated as of 12 o'clock or noon today, Central Time. And you can find the updated graphs on our website, water.sam.usace.army.mil. With the updated graphs. So the points that you see, the 4 points are close to 192, excuse me, 192 elevation, feet in elevation. Those points have been dropped significantly towards the top of conservation, and that is due to us generating more at the project, and that will be pushing more water downstream. If you go to that next slide, please. And then at Jim Woodruff, we're holding pretty steady right now, and we're probably going to be operating around 77 feet in elevation. Our discharges will be going up because of the storm once more, but we're looking to be in a really good place as long as inflows hold and as long as we get that water from Walter F. George and West Point. If you could go to that next slide, please. We're still in composite zone 1 for our ACF basin composite conservation and flood storage. Before we were slightly riding like right towards the middle of this composite zone, but now we're towards the top and towards top of conservation. You go to that next slide, please. So in the end, inflows into the project are normal now with this past rain event. Although we did get a lot of rain, we didn't have to go into flood operations or induce surcharge because most of the inflows were well below what we need, what is dictated in our water control manuals. Currently, all projects but Beaufort are currently above top of conservation or getting close to. And then Lake Lanier, West Point, and Walter F. George are currently in zone 1. Lake Lanier, Beaufort is continuing to fill to top of conservation. Water management is prepared to go to flood surcharge operations if needed, especially with this upcoming storm. It's looking as though it's going to hit right on the ACF basin once more. The ACF system conservation storage is in zone 1 and it's forecasted to remain in zone 1 for the next few weeks. Thank you, Rachel.
Thanks, Jody. And now Sam Lucas is up with our Apalachicola Bay daily average salinity levels. When you're ready, Sam.
Thank you, Rachel. All right, so last month we left off with data through the end of April. So this will be an update from April 28th through June 9th. Let's just take a quick look at this map before we go over the data. I will ensure that next month we have a labeled map to make it easier. But if you look at the icons that have the yellow square with the raindrop on it, toward the top, that is our East Bay water quality station, and we'll be focusing on that today, as well as one directly south of it, that's Cap Point. And then if you look west across the bay, that's our dry bar station. Both Cap Point and dry bar are located on historic oyster bars. And all three of these water quality stations collect data 365 days out of the year at 15-minute intervals. And we can go ahead and get started checking out that Cap Point data now. Okay, and again, we're looking from the end of April through June 9th. Now, when you look at this, the salinity values experienced a large increase mid-May, and it peaked on May 22nd. The values went from 15 parts per thousand on May 14th to 30 parts per thousand on May 22nd. And in a little bit, you'll see that East Bay follows a similar pattern. Then the values fell and are currently within the 25th to 75th percentile range as of June 9th. And I'll be interested to see how things change throughout the summer. Now, when I was checking out that time period in mid-May, no extreme tide events occurred during this timeline. However, river discharge decreased throughout the month of May, and there was little rainfall in our area. Also, during the period of rapid increase, we experienced high winds in the east to east-northeast direction, and we believe the combination of these factors caused this increase in May at Cap Point. All right, we can move on to dry bar next. Now, dry bar is quite variable. The values have fluctuated in May through the beginning of June, but this is pretty much the trend at this station. And the values are currently within the 10th to 24th percentile range as of June 9th. There are large fluctuations at this station because river water runs west through the system, and due to dry bar's position, it's impacted by this and tidal influence from Indian and West Pass. So it's pretty hard to pin down the exact causes of each at dry bar. All right, we can move on to East Bay Bottom. Now, our East Bay Bottom station, as I mentioned, it's following a similar pattern to Cap Point. The salinity values also spiked in mid-May, and they increased very dramatically, the most I've ever seen them increase, from 0.26 parts per thousand on May 14th to 23 parts per thousand on May 22nd. And they've gradually declined into June. I would think that this is the same reasons as Cap Point. The wind and the decrease in discharge and rain during the month of May most likely contributed to this. And this station is very impacted by the river just due to its proximity. So when we have lower flow events or the discharge decreases, you'll see that reflected in the station. All right, and then here's our summary. Just touching on everything that I said is that we experienced large increases at Cat Point and East Bay Bottom during the month of May. And I will be interested to see how they fluctuate throughout the summer, especially as we have storm events. Thank you.
Thank you, Sam. And now we have Todd Hamill with our Streamflow forecast to wrap it up before our guest speaker. When you're ready, Todd. Hey, Todd, I cannot hear you yet. Still can't hear you, Todd.
Hello?
There we go. I got you now.
Oh, I apologize. I tried to talk earlier to see if you could hear me. So there we go. So this is looking at our potential for inflows into Lake Lanier up at the top of the basin. And right now, you know, we have a pretty good spread, and even at the end of this period. And so, but it looks fairly normal for this time of year. We're usually getting to kind of a low part where we don't see as much flooding this year, and we'll see a graphic about that in just a little bit. So let's go ahead and move downstream and look at another point. And here's the Chattahoochee River at Whitesburg, which is below Lake Lanier. And we can see pretty normal flows, nothing excessive in those areas based on, again, model output, meteorological model output during that time. And so things are looking, again, pretty normal, nothing very high and also nothing very low. We're not dropping down quite as much. So let's go down, let's move down a little bit. This is, now we're going on to the other part, the Flint River, and these are uncontrolled. So you can see we do have a little bit of fluctuation, and you can see at the very beginning of this time frame where we've had rainfall from Claudette that has it at higher flows. But as we go forward, the rainfall looks fairly normal for this time of year, and that these flows look normal, and so we're in good shape on the Flint River now also. Let's go ahead and go to the next slide, and then we're moving a little bit further downstream on the Flint River at Albany. Again, we got plenty of water from Claudette on the creek side of that part of the basin, that we've got kind of some action stages and some bankful rises in those areas. So we do have a lot of water moving in the bottom part of this basin, which means that will get down to Woodruff Reservoir. So those, again, those are in pretty good shape. We may end up seeing some action stages at Woodruff and Bluntstown below that because of all the water we have on both the Chattahoochee and the Flint River side. So let's go ahead and go to the next one. And this shows that water potentially getting to action levels at Bluntstown below Woodruff Dam. And that's just because we've got lots of water coming from both sides, and so the potential is for us to have potentially an action stage or bankful rise at Bluntstown. And but again, this makes it look, as we look forward, less likely that we'll get into any drought situation. So let's go ahead and go to the next slide. And so as we look at our Southeast climate climatology for flooding in the Southeast, we're at week 25 or 26 right now. And that's really kind of a low time for us this year. As we get into May and June, we don't have quite as much flooding during that time. And a lot of that's because we're in between seasons. We're in between our winter recharge season and our hurricane season and kind of our pop-up thunderstorm type season. So this is a time when we don't expect a whole lot of flooding, but it becomes more spotty as we go forward. And so that's where we are for this time of year. And in this most recent event, we did have some rainfall, but we had very few points go to actual flood. We have a lot at bankful, but very few go to flood. So for the next month, it looks like we're near normal conditions. As David mentioned earlier, it looks like we might have above normal temperatures and above normal precipitation. If we just had normal precipitation, things would really kind of start to dry out. Having normal precipitation will help, or above normal, will help things and probably keep us normal without having much flooding. That's assuming we don't see any more tropical systems come through. So we'll just have to see about that. So when we look at the 3-month outlook, which is the next one, the next slide. And so we pretty much have equal chances of there's above and below. The green part shows the chances for above normal stream flows, and the reds show the chances for below normal, and the yellows show for normal stream flow. So our chances for slightly above or normal stream flow are higher, and right now it looks like the chances for us getting below normal during this time and going into drought are not quite as high as they are sometimes getting into the summer. So I think that's good news looking through the summer period and into the early fall. And then our last slide, our overview, and no flooding really expected over the next 10 days, a couple of bank full rises possibly. Our 1-month stream flow forecast is near normal, and part of that reason is because Claudette helped reverse some of those trends that we were seeing where things were starting to dry out some and we were starting to see some issues, but I think Claudette has helped that. And so we're in good shape as we get to the end of June and going into July. And our 3-month stream flow forecast, again, as I mentioned before, looks near normal. And that's good news. Again, Claudette kind of helped that without having it really too much flooding in the area. We reverse things, are in good shape going forward. And that's it from me.
Thank you very much, Todd. Now I'm going to turn it over to our special guest speaker, Mike Hobbins. And just a note to the audience, and also I'd like to apologize to Mike. We will have to make sure we finish at least a few minutes before 1 p.m. so that 2 p.m. Eastern, so that national flash drought webinar can get started. So I won't take up any more of your time, Mike.
Okay, I hope you can hear me and see my title slide.
Looks great.
Okay, great. So yeah, I'm Mike Hobbins. I sit in Boulder, Colorado. I'm with Ceres and the University of Colorado, but I work at the Physical Sciences Lab. And this is EDDI is a collaboration for a bunch of different agencies, as you can see here. So I'm going to talk about basically what is EDDI, what isn't EDDI, why would we use evaporative demand, which is the ED part of EDDI, to examine drought, and show you just some of the sorts of products and formats of the data that we can provide to the ACF. So this is a typical map of EDDI, and you can see here there are warm colors and cool colors, and warm colors indicate drought of increasing or of various categories, and cool colors are the reverse. They're wetter than normal conditions. So this is a 2-month EDDI, which means it's an EDDI month is 30 days long. So this is 60 days EDDI ending on June the 15th. And you can see here there's no Claudette fingerprint here whatsoever, because this is before Claudette. So EDDI is always about 4 days late, which is a drawback that we're limited to by our driving variables. And you can see here that the names and colors and percentile breaks for EDDI are almost, well, they are the same as the US Drought Monitor, and you can see ED4 would represent D4 on the Drought Monitor, for example. And then there's reverse the wetness. It's a multi-scalar index, as I'll talk about later, and I produce it at 24 timescales, 1 to 12 weeks and 1 to 12 months. So in this map, like I said, you see these warm colors, like in southern Florida, where evaporative demand, that's E0, is unusually high, indicating drier than normal surface conditions. And in western Tennessee and Kentucky, you see wetter than normal surface conditions. So you presume that the land surface is wetter than normal there. And for example, up in Northern Virginia, we see ED3, which if you look down at the drought categories, you would expect to see those conditions for that 2-month period only 5% of the time. So basically, EDDI is the anomaly in evaporative demand at a specified timescale at every location, and it's expressed as a percentile. Okay, so what is evaporative demand? I won't spend a lot of time on this. It's not ET, it's not evapotranspiration or evaporation. It is the theoretical evaporation that would happen given an unlimited moisture supply. So it's basically, it's the thirst of the atmosphere. The thirstier atmosphere when the atmosphere is thirsty, it's generally as a result of the land surface being dry, and a thirsty atmosphere will then dry out the land surface. We use reference ET, which is a good physically based estimate for monitoring drought. So if you think about why do we use evaporative demand in drought, this is just a cartoon of a developing drought from left to right. You know, you can start with low evaporative demand, and that when you have a low precipitation, the precipitation, the moisture supply is capped. It evaporates due to, for example, due to high temperatures and clear skies. As that moisture supply declines, there becomes a point where evapotranspiration crashes. Soil moisture depletes rapidly, evapotranspiration declines, and all the energy that would have gone into evaporate is now heating and drying the atmosphere and increasing evaporative demand. So even though ET is now low, the thirst of the atmosphere is high and the evaporative demand is high. If you like to look at it as sort of a time graph, here we go, as time along the x-axis, evapotranspiration, that's the actual flux of evaporation and transpiration, can increase when you have a drier atmosphere come on, pass through a wet surface, pass over a wet surface. Evapotranspiration will increase until the moisture supply crashes, and then evapotranspiration will decline, but evaporative demand will increase. I don't know if that helps at all, but in any kind of drought, evaporative demand increases. That's why we like to use it for drought monitoring. Okay, so enough background. How do I produce evaporative demand that we then put into EDDI? Well, we use the Penman-Monteith reference ET. It's a fully physical evaporative demand metric. It takes into account radiative forcing and the advective forcing, so wind, humidity, soil radiation, and temperature. And you can see on the map here, this is the mean annual evaporative demand. And where it's hotter, drier, windier, or sunnier, for example, in the Southwest, evaporative demand, E0, is high. And you know, where it's cooler, moister, evaporative demand is low, up in Maine, for example. Okay, so I produce it 5 days late because that's the driving variables. They're only available 5 days late. I produce it from the NLDAS reanalysis data system, which produces data at about 12 kilometers across the continental US. So I take the, I produce it daily from 1979 all the way through to 5 days ago using these inputs. I calculate reference CT, and then I aggregate reference CT according to whatever time scale I'm looking at. That 2-month map we saw in the very beginning would be temporally aggregated reference CT for 2 months. And then I rank it according to how that 2-month period compares to the 42-year climatology, and I produce EDDI. EDDI is a standardized index, so it's got a standard normal distribution. It looks like this. When you're over here on the far right, you're in extreme drought. When you're over here on the far left, you're in extremely wet. And then we just map those percentiles, and we produce that map you saw in the beginning. So EDDI is multi-scalar, like I said. I can produce it from 1 to 12 weeks and 1 to 12 months. And here's just a sample of EDDI that was available on June 15th when I put this slide together. It's not the latest available, but it matches the US Drought Monitor on June the 15th. And these maps don't look the same because obviously this 1 week is only looking back 1 week, whereas this 12-month is looking back the entire year. But it captures, being multi-scalar, it captures dynamics, drying dynamics and wetting dynamics that happen on different timescales. So the optimal timescale would be specific to your region, to your season, and to whatever sector you're in, whether you're in recreation or irrigated agriculture, for example. So what can we use it for? What is it used for? Well, it's used for agricultural drought because it really reflects soil moisture very well, both in farming and in ranching and in irrigated farming too. It's good for hydrologic drought because it reflects snow accumulation and snow melt, which may not be that important for the ACF. And it's becoming increasingly important in fire risk monitoring. What it is not, though, it is not a measure of meteorological drought. So it's not a precipitation deficit. There's no precipitation input into evaporative demand, but it does reflect the wetness of the surface through soil moisture. So you can use it across sectors, basically. And here's an example of EDDI looking at the Great Drought in 2002 across the western US. And you can see this is a drought monitor in the top left. for July 31. This is a 3-month eddy on July 31. So for the 3 months ending July 31. And you can see the patterns look very similar. I mean, they're not the same, clearly, and we wouldn't want them to be the same because we want EDDI to bring something new information to the table. But you can see it's got this sort of bilobal drought here in the high plains and the southwest, and it's very similar to this pattern in the US Drought Monitor. It's also very similar to VIC model soil moisture and to the evaporative stress index, which is a different metric that looks at actual evapotranspiration. So it does a good job of monitoring agricultural drought here. It also provides early warning of flash drought, and this is just an example of a paper we produced for this Wind River Indian Reservation in Wyoming, where they saw a drought. The US Drought Monitor never saw a drought, but we saw it flash in and flash out as you track here from May, which is super wet, through the summer and into the late summer, where very quickly we developed this drought here where people on the ground reported impacts, but the Drought Monitor didn't report anything in the reservation until September 29th. So we like to think that EDDI provides early warning of flash drought, for example, and this is another example in 2012, the Midwest drought of 2012, where EDDI was 2 months ahead. 2-week EDDI is here on the left, and the Drought Monitor for the same periods is here on the right. And 2-week EDDI really bloomed into ED4, which is the exceptional drought, in June and July, whereas it wasn't until August that the US Drought Monitor caught up. So the question is, one of the questions that we have is, if we had actually been looking at evaporative demand during this period in 2012, when EDDI didn't exist yet, would we have spotted this as a flash? Would this have still been a flash drought, or would that early warning have obviated that category? Okay, this is not really this relevant to the ACF because it's about snowmelt, but it does show good indication of impending low stream flow in California, at least. But this is, I thought, somewhat interesting to wildfire risk in your region. There's a very strong relationship between fuel moisture and EDDI. And we have a paper here which I can provide you if you want it, where EDDI provides early warning of wildfire risk. And if you recall the 2016 drought and wildfires, just I guess in the northern half of your region, or maybe a little bit outside of your region, what I've done here is I've looked at EDDI over this box through 2016, and I'll show you a graph of EDDI as we march through the year to the wildfires that broke out in 2016. And I'll show you, this is a graph, a time series from the beginning of the year through to the beginning of the next year, showing this anomaly in evaporative demand. So basically this is what's driving EDDI, this black dotted line, and this is 1 month EDDI averaged across that box. And what these colored lines show are the contributions to this anomaly by each of these drivers, the solar radiation, the wind speed, the humidity, and the temperature. So as we march through, this is a 1 week, this yellow panel sort of marches through in 1 week increments. I guess not 1 week, 1 month. Evaporative demand is far above normal throughout the entire year, and it's way above normal in the summer, and then remains above normal in the fall. But because evaporative demand is normally lower there, you see this ED4 bloom, and then the fire breaks out in late November. So this would have been a good indicator of impending wildfire risk conditions.
Hey, Mike, I just want to give you a warning. We have about 2 minutes left.
Okay, so all right, I'll hurry through. This is how I can provide EDDI to you. These are change maps in EDDI. So this is 1 month EDDI May 15th. This is 1 month EDDI a month later, and this is the difference. And this is actually shows you what's blooming and what's ameliorating as you march through these periods. And you can see that for example, it's drying in Florida over this month. And we can obviously produce those change maps at different time scales and across different periods. Okay, I'm not going to show this, but this is where you can get EDDI. EDDI has a web page which you can search. If you search for EDDI NOAA, you'll find this web page, and it has a bunch of tabs which can help you find resources for the user guide and papers and related links. You can get an archive of EDDI and generate a historical time series, and there's a team biography page because we're all so good looking. But EDDI is also available in a variety of formats. These are maps I produced for a bunch of stakeholders. This is Washington. You can see I put in watersheds here. This is for the Rosebud Sioux Reservation in South Dakota. They wanted their boundaries, and Rapid City WFO, they wanted the cities and the roads. Or I can produce the actual raw data and hand that off. So finally, this is where you would get EDDI. I will just drop these links in the chat, but if you have any questions about this, you can either ask now, or you can contact me at mike.hobbins@noaa.gov. I'm happy to set it up for you. I have set up a Southeast DO's EDDI web page where you can download or just look at maps and that are updated daily. And I will put that in the chat right now.
Thank you so much, Mike. And we'll include all of this information that you have displayed right now about accessing EDDI in our follow-up email to everyone. And if you have questions, you can follow up with Mike. You can also email me. Thank you so much. I'm sorry that we were rushed towards the end, Mike. And thank you for being here, everyone. Our next webinar will be July 27th at the same time. Have a great day.
Wait, one thing. We have a request, Mike, to actually complete your talk and take some more questions and answers. So who knows, maybe we'll get to that at some point. But if you have any questions and answers, you can at this point reach out directly to myself or to Rachel. This is Meredith Muth, or even to Mike. Mike, that was a great presentation. I didn't know about the Southeast DOs, and we will definitely follow up on this. I think it's a great opportunity for flash drought monitoring. So thank you all. Have a wonderful day.